Hello students, welcome to the lecture on power and authority. After this lecture, you will be able to learn the following objectives. Understand the concept of statistics, describe the importance of statistics in business, explain the statistical averages or measures of central tendency, explain the semi-interquartile range or quartile deviation, understand the measures of dispersion, examine the mean deviation, explain the standard deviation, understand the concept of skewness and measures of skewness. Today in this session we will talk about statistics. So what is statistics? It is complicated? No, it is very easy to understand. It is very easy to interpret. Now when you look at your textbook, you might be overwhelmed by all the information. So what you have to do is easy, just simplify it. So statistics is a way to get information from data. That's it. Statistics may be the single most important subject matter you ever study. This is because through your entire life, you will be inundated with statistics. Consider a few examples. People tend to be more persuasive when they look others directly in the eye and speak loudly and quickly. Women make 75 cents to every dollar a man makes at the same job. A surprising study shows that eating egg whites can increase lifespan. 79.48% of all statistics are made up on the spot. Now, although some of the statistics are not true, they are everywhere. They are in psychology, health, law, sports and business, and in every other discipline. Statistics are often added in reports to add credibility. Many of the statistics provided are not accurate. They are often easily accepted and mislead people, especially people who are not informed about statistics. It is extremely important to understand statistics because statistics influence which findings we are going to believe and which findings are going to influence to make changes in our life. So it is important to become a consumer of research and of statistics. Concept of statistics. The specific definition of statistics is the mathematics of the collection, organization, and interpretation of numerical data, especially the analysis of population characteristics by inference from sampling. The definition of statistics given by Horace Seacrest points out certain characteristics. These are: statistics are aggregate of facts. Single and unrelated figures are statistics. A single age of 35 years or 55 years is not a statistics but a series relating to the ages of a group of persons would be called statistics. Thus, statistics are a number of facts. Statistics are numerically expressed. All statistics are numerical statements that are expressed in numbers. Qualitative expressions like good, bad, young, old, etc. do not constitute statistics. Importance of statistics in business. The scope of statistics has considerably enlarged in the modern time. It is customary to classify studies of statistics into the following two broad categories: descriptive statistics and inferential statistics. Let us describe the first. Descriptive statistics means to describe a phenomenon, summary, and presentation of data. For example, in a conference, someone is presenting charts, pie charts, bar charts, and all these different visuals for better understanding. And that is what descriptive statistics is. Inferential statistics, on the other hand, is to draw conclusions, making statements or predictions about the population based on statistical information. Let us now look at the division between descriptive statistics and inferential statistics. Now, this distinction is based on what we are trying to do with our data. With descriptive statistics, we describe or summarize things. With descriptive statistics, we describe or summarize things we definitely know. For example, let's say you have a list of all senior SAT scores of a high school. Suppose you want a better feel of the scores for the kind of students you have. So to do this, you can make a graph, a chart, or a table displaying their SAT scores. This chart shows the mean or average SAT score of the school. This is an example of descriptive statistics, summarizing or displaying the facts known to you. Now with inferential statistics, you are doing more than just describing. You go to compare groups, test a hypothesis, or make predictions. For example, suppose you hear a television commercial claiming that the gas mileage for a certain model car is 30 miles per gallon. You doubt the claim and you want to test it. The car company will make hundreds of thousands of these cars every year, and it is not practical for you to test the gas mileage on every one of them. But you might go to various showrooms that sell this model and randomly pick and drive only 50 of these cars. Then you can use this information to figure out whether all cars of this model average approximately the gas mileage claimed by the ad. We assume that the 50 cars we picked are representative of the hundreds of thousands of cars in the population. When we say the 50 cars are representative of the population, this means that we hope that the 50 cars are not somehow different from all the cars of the same make and model that we could have chosen. We use the small group of 50 cars to infer or conclude something about the population of cars they come from. This technique is part of inferential statistics. It is how we say something about a group when we haven't been able to test each group member. The big difference between these two divisions is this. When we illustrate or summarize facts about data we already have, we are doing descriptive statistics. When we attempt to compare, test, or predict something about a group we haven't examined directly, we are doing inferential statistics. Distrust of statistics arises due to the direct or indirect influence of certain causes. These causes can be to ignore limitation of statistics. The science of statistics has certain limitations. It is necessary that these limitations should be taken into consideration while applying statistical methods. If these limitations are not taken into consideration, then the results will be doubtful. Misuse of the figures. According to King, statistics is clay out of which you can make a god or devil as you please. It means that statistics are misused by selfish people. If statistics are misused, fallacious conclusions may be arrived at. Inadequate sample data may lead to misleading results if the investigator jumps to a conclusion based on too small sample or one which does not represent the universe adequately. Lack of subject knowledge. Most of the people are not aware of statistics. They do not know what statistics is and what its importance is. If we get our data collected through such people, the collected data would be incomplete and unreliable, and the results based on such data would be unreliable. We need a few remedies to remove this distrust. Need of caution. Investigators should be careful while using statistical data. If he is cautious throughout the process of collection of data, then the results would be correct and reliable. Statistical limitations should be taken into consideration. To remove the distrust of statistics, limitations of statistics should be taken into consideration. For example, data should be uniform and homogeneous. Self-restraint. This means that the investigators should not be biased while collecting and making use of data. If the investigator thinks that the data is not reliable, he should not accept them. Statistics must be used by experts. Statistics must be used only by those people who have subject knowledge. According to King, the science of statistics is a most useful servant, but only of great value to those who understand its proper use. Analytical study of data. Analytical study of statistical data is necessary before they are used. By analyzing the data, we can separate the homogeneous and heterogeneous data. Properly analyzed data will give reliable results. Statistical averages or measures of central tendency. Let us see how arithmetic average is calculated in individual series. Arithmetic mean: the sum of all the numbers in a list divided by the number of items in that list. This is Charlier's accuracy check. Combined mean is given by this, where x12 is equal to combined mean, n1 is equal to number of items of the first group, n2 is equal to number of items of the second group, x1 is equal to arithmetic mean of the first group, x2 is equal to arithmetic mean of the second group. Weighted mean is given by this, where x bar w is equal to weighted arithmetic average or weighted mean. Sigma wx is equal to total of products of weights and the variable. Sigma w is equal to total of weights. Semi-interquartile range or quartile deviation. Let us see how quartile deviation is calculated. QD is equal to Q3 minus Q1 by 2, where QD is equal to quartile deviation, Q3 is equal to third quartile, Q1 is equal to first quartile. Now the coefficient of QD is calculated by Q3 minus Q1 divided by Q3 plus Q1. Measures of dispersion. A measure of dispersion is designed to demonstrate the extent to which the individual measures differ on an average from the mean. According to Dr. A.L. Bowley, dispersion is the measure of the variation of the items. According to Broker and Dick, dispersion or spread is the degree of the scatter or variation of the variables about a central value. The measure of dispersion is also known as averages of second order. The simplest method of measuring dispersion is range. Range is defined as the difference between the highest and lowest values in the series, where R is equal to range, L is equal to largest value, S is equal to smallest value. Now the coefficient of range is calculated by L minus S divided by L plus S. The merits of range are: it is easy to calculate, it is easy to understand, it does not require any special knowledge. The demerits of range are: only two extreme values are taken into consideration. It is affected by extreme values. It is not possible to find out the range in open-end frequency distribution. Mean deviation. This is how mean deviation is calculated of individual series, where MD is equal to mean deviation, mod D is equal to deviations from mean, median or mode, ignoring plus and minus signs. Mean deviation calculated of discrete series is shown on the screen, where sigma f mod D is equal to sum of the products of frequencies with deviations taken from mean or median ignoring signs. The same formula is adopted in continuous series. The coefficient of MD from mean or mean coefficient of dispersion is given by MD over mean. Coefficient of MD from median or median coefficient of dispersion is given by MD over median. Coefficient of MD from mode or mode coefficient of dispersion is given by MD over mode. Standard deviation. Now we shall see how standard deviation is calculated in individual series. First is the direct method. Sigma is equal to root of summation x square over n, where sigma is equal to standard deviation. Sigma x square is equal to sum of the squares of deviation taken from actual mean. N is equal to number of items. The shortcut method for calculation of standard deviation is as shown, where dx is equal to deviations taken from an assumed mean. The calculation of standard deviation in discrete series by direct method, shortcut method and step deviation method are shown, where I is equal to magnitude of the class intervals. The coefficient of standard deviation is given by ST over mean, which is sigma over x bar. Skewness. Skewness is given by difference of mean over mode. Now, if the mode is ill-defined, then skewness is given by 3 times mean minus median. And if we also have skewness equal to third quartile plus first quartile minus twice median. Let us take a look at the relative measures of skewness. Karl Pearson's coefficient of skewness is given by mean minus mode over standard deviation, where J equal to coefficient of skewness, Z equal to mode, X bar equal to mean and sigma equal to standard deviation. Bohle's coefficient of skewness is given by third quartile plus first quartile minus twice median over third quartile minus first quartile, where Q3 is equal to third quartile, upper quartile, Q1 is equal to first quartile, lower quartile, M is equal to median. Summary. Let us summarize what we have learnt today. Statistics are aggregate of facts. All statistics are numerical statements that are expressed in numbers. The science of statistics has certain limitations. It is necessary that these limitations should be taken into consideration while applying statistical methods. A method of dispersion is designed to demonstrate the extent to which the individual measures differ on an average from the mean any other.